Hi to all. In this video, we are going to see Hopkinson test of a DC machine. Mm, this is an elegant method of testing. This is an indirect method of um, DC machine. This is an elegant method of testing DC machines. Here, it will be shown that while power drawn from the supply only corresponds to no load losses, if the machine of the machine. The armature physically carries any amount of current which can be controlled by and with cases. Such a scenario can be created using two similar mechanically coupled shunt machine. Okay, uh, two similar in the sense one acting as a motor, another is acting as a generator. Okay, electrically, these two machines are eventually connected in parallel and controlled in such a way that one machine acting as a generator and other acting as a motor. In other words, two similar machines are required to carry out this testing, which is not a bad proportions for manufacturers as large number of similar machines are manufactured. Okay, this is a machine. Here, this acting as a motor and this acting as a generator, and this will be mechanically coupled. And here we are going to measure the current, and here we are going to measure the voltage between this end to this end. Okay, and this coil is for motor field coil, and this coil is armature generator field coil, um, and with the rheostat of this one and rheostat of this one. Procedure: connect the two similar, okay, uh, same rating coupled machine as shown in the figure, uh, with switch S opened. Okay, the first machine is run as a shunt motor as rated speed. By varying this one, we make the field rheostat, uh, by varying the rheostat of a field rheostat, and we are making the motor has to run at a 1500 rpm or rated speed. Okay, um, it may be noted that the second machine is operating as a separately excited generator because its field winding is excited and is driven by the first machine. Field winding is excited and driven by first machine. Okay. Uh, Now the question is, what will be the reading of the voltmeter connected across the open switch of this one? Okay. Uh, The reading may be either close to twice supply voltage or small voltage. In fact, the voltmeter practically reads the difference of the induced voltage in the armature of machines. Okay, the upper armature terminal of the generator may have either positive or negative polarity. Okay. If it happens to be positive, then voltmeter reading will be small, otherwise it will be almost double the supply voltage. Since the goal is to connect two machines in parallel, we must first ensure voltmeter reading is small. In case we can find voltmeter reading is high, we should switch off the supply, reverse the armature connection of the generator, and start a fresh experiment. Now voltmeter is found to read a small, although time is still not ripe enough to close S for paralleling the machine. Any attempt of closing the switch may result into large circulating current as the armature resistance are small. Now we are adjusting the field current of generator IFG of the generator, then the voltmeter readings may be adjusted to 0. So EG approximately equal to EB, and S is now closed. Both the machines are now connected in parallel. Loading the machine. After machines are successfully connected in parallel, okay, we go to the load. we go for loading the machine, that is increasing the armature current. Just after paralleling, the ammeter readings A will be close to 0 as Eg approximately equal to Eb. Now if IFG is increased by decreasing RFG. RFG is a resistance connected to the field coil of a generator. Then Eg becomes greater. The generator voltage becomes greater than the back EMF, and both IAG and IAM. IAG is nothing but generator current of armature, and IAM is nothing but armature current of motor increases. Thus, by increasing field current of a generator, okay, one can make EG value is greater than EB, so as to make the second machine act as a generator and first machine as a motor. In practice, it is also required to control the field current of the IFM, that is motor field current, to maintain speed constant at rated value. The interesting point to be noted here is IAG and IAM do not reflect in the supply side line. Thus currents drawn from supply remains small. Okay. The loading is sustained by the output power of the generator running the motor and vice versa. The machines can be loaded to full load current without the need of any loading arrangement. So the another name of the test is full load test indirect method. Okay. Calculation of efficiency. Let field current of the machines be also adjusted that the second machine is acting as generator and first machine acting as a motor. Okay, acting as a motor with the current IAM as shown in the figure. Okay, also let assume the current drawn from the supply is I1. Total drawn supply from the V1 VI1, which goes to supply all the losses, namely copper loss and armature and field rotational losses of the both the machines. Power drawn from the supply VI1, field copper loss for motor VIFM, field copper loss of generator VIFG, armature copper loss I square or AM, armature copper loss of generator I square or AG. Okay, rotational losses of both the machines VI1 minus VIF plus VIF plus I square AM or plus I square AG or. Since the speed of the both the machines are same, it is reasonable to assume the rotational losses of both the machines are equal, which is strictly not correct. Field current of the generator will be bit more than the current of the motor. Thus, the one's is estimated from the can be proceeded. Calculated the efficiency of the machines as follow. Rotational loss of each machine P dot is equal to VI1 minus VIF F of motor plus VI F of generator plus I square AM of motor and plus I square AG of generator or by 2. Efficiency of the motor, okay, as pointed earlier, the efficiency calculation of the motor calculate the input power and then subtract the losses to get the output mechanical power as shown below. Okay, so here efficiency P out by P in, efficiency of generator losses. Okay, here VIG, okay, advantage will get P out by G by PAT. Okay, advantage of Hopkinson test. The merits of the test is required very small power compared to full load power of the motor generator coupled systems. Temperature rise commonly observed maintain limit because of the test is done under full load condition. Changes in the iron due to flux distortion can be taken as one of the advantage of the full load condition. Disadvantage, the merit of the test. Okay, it is difficult to find two identical machines needed. That is one of the demerit. It is not possible for separate iron losses to find a value. The difficulties of